Last lesson, inverse functions. Guys, whenever you see f to the -1 of x, this is talking about an inverse function. So today what we got to talk about is, what is an inverse function? Well, let's look at three different versions. Let's look at a table first. So here, this is your function right here. This is f of x, and this is your inverse. Now, what do you notice? Same numbers, but they've switched. My x's are now the y's, and my y's are now my x's. So the coordinates have flipped. Okay, that's an inverse. Here, if you're going to look at a graph, this is the original line right here. This is the f of x, and then here's f -1 of x, so inverse of f. Now, if you notice, I drew this line in the middle because another way to actually check if it's an inverse is imagine a reflection over this line. If you take this and flip it over the line, you would get this other line. So they don't exactly have a lot of points in common. Maybe only one, maybe two, but they are not the same line. They're not parallel, they're not perpendicular either. So how do you know what the lines are? That's when we get to the algebra part. If this is the function and this is the inverse function, one way to treat this is change this back to mx plus b. Let's go back to y equals mx plus b, okay? So we have right here the function with y, right? To turn it into the inverse, the first thing you do is flip x and y. Replace them with each other. So we put x over here and we put y over here. Now, that doesn't make sense because when we solve for our equations, usually it equals y. So now let's solve for y. Let's solve this problem for y by getting rid of the numbers that are with it. So let's start with the -1. How you get rid of a -1? Inverse operations, you add 1. Then you get this. Okay, now you got to get rid of the 1/2. What is the inverse of 1/2? 2. Multiply that, they cancel out. Whatever you do to one side, you got to do the other. Multiply this by 2. But you have to distribute, and you end up with this. And now the y is by itself. So your new function, your inverse function, is 2x plus 2. So what do you do? This. You replace the x and y. You flip them. And then you solve for y again. And that will give you the inverse function. So let's do some examples. Okay? Okay. If there's a table, and let's just say this is linear, right? So the pattern here, it's going down by 4. So then I know this was 15, and I know this was 3. When I fill it out over here, these numbers now take the place of x. And these numbers will now take the place of y. Okay, and if we do a very quick graph, sorry, just trying to make this quick, 15, 11, 5, 7, 7, 3, you would have a line that looks like this. You have a line that looks like this, okay? But now, if we do this, right, and you take all these points, when you get to 3, which would be, let's see, down over here, 3, you're at 7, so 3, 7, somewhere over here, right? And then you would get 15 is 1, is all the way down here. 15 is going to be somewhere over there. It's going to be a weird kind of line that flipped, okay? But if you graph them, you would get the inverse line, all right? Now, we're not going to focus much on the graphing because I think that's going to make it a little bit more complicated. Just focus on the inverse points, okay? Now, here, if we do this, we're going to change this to y, like that. Okay, that's what we're used to seeing. That's the function. But if you want the inverse function, we change x and y and now they're in different places. And then we solve for y. So how do we solve for y here? Well, how do you get rid of a fraction with the inverse fraction, the opposite fraction, 2 over 1? You multiply that, they cancel out. Whatever you do to one side, you do to the other. So you're going to multiply that by 2 over 1. The 1 really doesn't matter. You have this. Okay, next. You're trying to get rid of the square root. How do you get rid of a square root? The inverse operation of that is to do the power of 2. We square it. And whatever you do to one side, you do to the other. So now you're going to end up with y equals 4x squared. So now the inverse function, the negative 1, f negative 1, is 4x squared. That's the inverse. That's a completely different function. This was a square root function. This is a quadratic. Okay? Doesn't have to stay the same. All right. Let's do one more. A linear one. Back to the ones you guys know well. Y equals mx plus b. But to change it to the inverse function, we switch out x and y, and now we solve for y. Starting with, get rid of that 2. Let's get rid of that 2. Now you have x plus 2 equals 5y. Okay, what's next? Gotta get rid of that 5. That 5 is multiplying. Inverse of that is dividing. Now the rule is, if you divide one number, you have to divide the whole thing. 5's cancel out. You're left with y equals x over 5 plus 2 over 5. So your inverse function, the inverse function is 1/5 x plus 2/5. And that's how you do an inverse function. You switch the variables and solve for y again. Okay. If I graph this one will be a little better. Sorry, because that first graph, I really feel it's a horrible graph. I apologize. But let's just say you have the first one, right? Negative 2. The slope is up 5 over 1. So 1, 2, 3, 4, 5 over 1. Okay. There's the first function. This is f of x. Okay. Now this function, we'll do it in a different color, starts at 2/5, which would be somewhere around the half right here. Now the slope is 1/5, so it goes up 1 over 5. 1, 2, 3, 4, 5. So somewhere over here. And there it is. There's the inverse function. Okay, so they're not parallel, they're not perpendicular, they're just the opposite function of this one. Okay, and that's it, guys.